Good evening, friends. This is Dr. Manjunath. Welcome to Unacademy's YouTube session. I shall be taking up the class on concepts of trigonometric identities. I would like to congratulate all the students who have got wonderful results in the recent second view examinations. At the same time, I wish them all the very best for their future competitive exams, especially the CET, which is coming up very early now, and followed by that the JEE and the NEET examinations. I'm sure this batch of students will all be remembered for their extraordinary work which they are putting it up. Hats off to their abilities, and we are all there with them. The whole teacher community will stand with the students for their bright future. Wishing them all the very best. Dr. C.K. Manjunath here with trigonometric identities. Trigonometric identities, when I speak, I always talk about the right angles. The right angle triangles. Trigonometric identities are the equations that are true for only right angled triangles. Any right angled triangle, if I take, this has got three sides which has been said as opposite, adjacent and hypotenuse. Hypotenuse is the longest side. Opposite would be the side which is opposite to the angle that has been created, and adjacent is the angle which is side by to it. Adjacent is always next to the angle, and opposite is the opposite angle. You can see it very clearly on the slides. Opposite, hypotenuse, adjacent are being described very systematically. Based on these things, 6 trigonometric functions were identified. The major 3 functions are sine, cosine and tangent. The other 3 are, we call it as their cofunctions. If I take the sine theta value, it is opposite divided by hypotenuse. The ratio of opposite side with respect to hypotenuse will give the sine theta. Similarly, cos theta, adjacent side by hypotenuse, and tan theta is the ratio of opposite by adjacent. These are the 3 major functions of the trigonometry. The original author, the Greek astronomer, he actually, when he thought about these concepts, he was really willing to calculate the distances between the gigantic objects like planets, stars, and the other entities in the universe. So he was using this concept for measuring that. Later on, it came into the practice of various applications. As you know, friends, today, this is very well used in the game theories. This is very well used in the design of various architectural views. This is very well used in various applications of artificial intelligence. So trigonometry plays a very vital role, and the identities of trigonometry has been spread across all the applications that we look at. Fine. The other three cofunctions are cosecant, which is hypotenuse by opposite, secant, which is hypotenuse by adjacent, and cotangent, that is cot, adjacent by opposite. We have abbreviated these terms in a very short manner because always saying sine, cosine, tangent, cosecant. Instead of that, we use it in a very simple words like sine theta, sin, cos, cos, tan, tan. So we don't use tangent theta. We say it as tan theta. We don't say cosine theta. We say cos theta. We don't say sine, but it is said sin only. But it will never create any sense for us. That much we must understand. Cosecant is said as cosec. Secant is said as sec, and cotangent is said as cot theta. Friends, based on this, there are few more contents that were derived. You can see on the left corner of my screen, sin theta is, its cofunction is 1 by cosec theta. 1 by cosec will always give us sine, because you can see the relationship there. Sine is opposite by hypotenuse, and cosec is hypotenuse by opposite. Same way, cos 1 by sec theta, secant and cos are reciprocally related. Adjacent by hypotenuse, hypotenuse by adjacent. In case of tan theta, it is 1 by cot theta. They are again reciprocally related. Tan is opposite by adjacent and cot is adjacent by opposite. Friends, other than this, we have other identities. These fundamental formulas have been derived very systematically. I have one more relation before we go on to this. One is cot theta is cos theta by sin theta. Similarly, if I say tan theta, it is sin theta by cos theta. Coming into the identity formulas, sin square theta plus cos square theta, it is always equal to 1. You can see it here. Sin square is opposite square by hypotenuse square. Cos square is adjacent square by hypotenuse square. Take the LCM of 2, hypotenuse square, and in the numerator opposite square by plus adjacent square. These two, according to Pythagoras, it is nothing but hypotenuse square. So hypotenuse square by hypotenuse square, it is 1. So sin square theta plus cos square theta equals 1. Similarly, the same formula can be said in the other two formats. Sin square theta is equal to 1 minus cos square theta. Send this cos square to the right, it becomes 1 minus cos square theta. Then cos square theta can be written as 1 minus sin square theta. So we have three relations from one formula, 1, 2 and 3. The other two formulas are 1 plus tan square theta is sec square theta. 1 plus tan square theta, if you say it as sec square theta, then tan square theta is equal to sec square theta minus 1. Tan square theta is equal to sec square theta minus 1. One more way you can say this, sec square theta minus tan square theta is equal to 1, you can say. So these are the three major ways you can talk about it. Next, 1 plus cot square theta is cosec square theta. Normally cosec is written with CSC. CSC today is one of the greatest branches, which is computer science. That is also said CSC. So 1 plus cot square theta is cosec square theta, which is CSC square theta. It can be said as cot square theta is cosec square theta minus 1, or cosec square theta minus cot square theta equal to 1. You can say in any. So these are some of the fundamentals. See, first 6 trigonometric functions, its co-functions, the connection, the relations between cot, cos, sine, or sine, cos, tan can be said, and then the identity values. Hope we are able to understand this, and my expressions are quite meaningful. We have come into one more picture. Now this looks like a lot of things have been put into this. We don't have to worry. It's not that complicated. Let me start from the central box here. 1, 2, and then I'll go here. First of all, as I say, all these measurements are done with 4 quadrants. We have got 4 quadrants. The first quadrant is between 0 and 90 degrees. Second quadrant is between 90 and 180. Third quadrant is between 180 and 270. And fourth quadrant is between 270 and 360. If I take the first quadrant, in that all these 6 trigonometric functions will remain positive. All the 6 trigonometric functions will remain positive in the first quadrant. In the second quadrant, only sine will be positive, rest will be negative. Sine is positive means cosec also will be positive, but rest of the things, whether it is cos, tan, secant, cot. So these 4 will be negative in that quadrant, second quadrant. In the third quadrant, tan is positive. In the third quadrant, tan is positive. That means even cot is positive over there. But other things, sine, cos, secant, cosecant, all these 4 values will be negative over there. And in the last fourth quadrant, cos is positive or secant is positive, remaining 4. Sine, cosec, tan, cot, they are going to be negatives in that. So like this, we have made first quadrant all are positive, second quadrant sine is positive, third quadrant tan is positive, fourth quadrant cos is positive. So to remember this, all students take coffee. If you put that A, S, T, C, you get that. All students take coffee. In that manner, we can remember this. We need not insist them to drink, but this is a general conclusion to remember that. Okay, it's a mnemonic, that's it. So let me start from 1, which is the box which is at the center. Sine of minus theta will always be minus sine theta. We need to remember this. Sine of any negative angle, sine of minus 35, if I say, it will be minus 35 degrees. Sine of minus 45, it is minus sine 45. So this is a standard rule to remember. Sine of any negative angle will be set with the sine of the negative of that sine angle, whereas cos of minus theta will become cos theta. Any negative angle put with the cos will be positive. Cos of minus theta is cos theta. I think it's not that difficult to remember. Tan of minus theta is minus tan theta. Hope these 3 things can go into our mind perfectly. Sine of minus theta is minus sine theta. Cos of minus theta is cos theta. Tan of minus tan theta. Okay. Let me come with one by one boxes from the starting one. First one, cos theta. It is sine of 90 minus theta. Please remember, whenever we bring in 90 or 270, the value of that particular trigonometric function changes to its other value. Like for example, sine for 90 changes to cos. Cos for 90 changes to sine. Tan changes to cot and cot changes to tan. Secant changes to cosecant, cosecant changes to secant. This is what you are seeing in the first box. See, pi by 2. Friends, this is one more thing that we need to remember. 90 is represented in the radian measure as pi by 2 value. 90 in the radian measure is represented as pi by 2 because 180 degrees is pi radians. This is what the calculation exists. So pi by 2 means it becomes 90. So 90 minus theta, sine of 90 minus theta is cos theta. Cos of 90 minus theta is sine theta. Tan of 90 minus theta is cot theta. Cot of 90 minus theta is tan theta. Secant of 90 minus theta is cosecant theta. Cosecant of 90 minus theta is secant theta. So 1, 2, 3, 4, 5, 6. See, these relations we need to remember very systematically. Hope it's not creating any confusions, nor I am adding too much into the first class. It's a very simple thing, but very essential for us to practice. Then, when it comes to 180 or 360 degrees, the angle will remain as it is. In terms of 360 I am speaking, the sine of 360 plus theta, 2 pi is 360. Sine of 360 plus theta is sine theta. Cos of 360 plus theta is cos theta. Tan of, it should have been 2 pi here, 360 plus theta, tan theta. Same way, if you take in terms of 180 degrees, pi's, sine of 180 plus theta, sine remains as sine, but it's going to go into the third quadrant, it will be minus sine theta. Cos of 180 plus theta, it's going to be in the third quadrant, cos will remain as cos, it will be minus cos theta. Tan of 180 plus theta, this is exactly tan concept. Tan of 180 plus theta in third quadrant, tan is positive, tan remains as tan. Hope this concept is clear to you. Now coming into sine 2 theta. These are all called multiple angles. See, till now we spoke only about first circle. When I go from 0 to 360, it is one circle that I take. Now, it can be compounded, correct? 450, 480, 460, 720, 740, anything it can be. When we go like that, we start measuring the compounded angles or multiple angles. So, sine of 2 theta is given as 2 sine theta cos theta. Sine of 2 theta. Sine of 2 theta is written as 2 sine theta cos theta. Cos of 2 theta is written in 3 different formats. One is cos square theta minus sine square theta. Friends, you need to be very careful. We have learnt a formula cos square theta plus sine square theta. That's a different one where it is 1. Whereas cos square theta minus sine square theta is cos 2 theta. 2 cos square theta minus 1 is cos 2 theta. How did this come? Sine square theta is written as 1 minus cos square theta. 1 minus cos square theta, what happens? Minus 1, minus of minus plus cos square theta. So cos square theta plus cos square theta is 2 cos square theta minus 1. Similarly, change cos square theta to 1 minus sin square theta, 1 minus sin square theta minus sin square theta, 1 minus 2 sin square theta. These are the three different formulas for cos 2 theta. Tan 2 theta can be measured as 2 tan theta by 1 minus tan square theta. 2 is not seen here. 2 tan theta by 1 minus tan square theta is tan 2 theta. Now these are the multiple angles. Similarly, we will be having 3 theta, which I will take little later. Now we have addition formulas. Addition is when we add two angles. There are additions, there are subtractions, there are multiplications. All, see, whatever we do in mathematical operations, all those things can be done here. Please remember that. Trigonometry doesn't have any exceptions. It's a part of mathematics. Only the thing is, it exceptionally deals all the concept through these 6 trigonometric functions. That's it. That is the beauty of it. In fact, in the beginning days, this was all pure theoretical aspect. Many students, many people had confusions. Why are we studying all that? When people started giving the applications of it, today we enjoy learning it in a very different platforms. Okay, coming into sine of alpha plus beta summation, it is sine alpha cos beta plus cos alpha sine beta. Sine of alpha plus beta, when I am adding two values, it is sine alpha cos beta plus cos alpha sine beta. Sine of alpha minus beta is sine alpha cos beta minus cos alpha sine beta. Same plus became minus here when you subtracted the values. Cos of alpha plus beta, cos alpha cos beta minus sine alpha sine beta. And with subtraction, cos alpha cos beta plus sine alpha sine beta. Coming into the tan, addition of two values, tan alpha plus beta, it is tan alpha plus tan beta by 1 minus tan alpha beta. Tan alpha tan beta. Tan of alpha plus beta. See here, you need to remember, if there is a positive, if we are adding two elements, they are added in the top and in the bottom it is subtracted. Tan of alpha minus beta is tan alpha minus tan beta by 1 plus tan alpha tan beta. This is the addition concept of angles. Friends, we saw in the beginning the simple angles with their identities. Then we started their complementary concept. Then we saw their supplementary changings. We saw multiple angles. Now addition and subtraction of the angles we saw. Last part of this is understanding of half angles, half angle concepts. Sine of theta by 2. See, if I take, this is, let me say, theta was 60 degrees. What will be theta by 2? It becomes 30. If I have 75, what is half of it? So like that. So theta by 2 will be the half of the angle that we have taken. Sine of theta by 2 equals plus or minus root of 1 minus cos theta by 2. This is a whole root for the complete function. Plus or minus root of 1 minus cos theta by 2. And cos theta by 2 plus or minus root of 1 plus cos theta by 2. Plus or minus root of 1 plus cos theta by 2, that is cos of theta by 2. Please students, don't get confused, and many a times it's my experience, when we ask sin theta by 2, here it plus comes. When we ask cos theta by 2, here minus comes. Never make mistakes. See, when in the starting, in the very first step, if we learn this in a systematic manner, then none of these mistakes happen. So I request, when you are putting this into practice, you must do it very systematically. This is going to help all of us very clearly. So sine of theta by 2 is plus or minus root of 1 minus cos theta by 2. Cos theta by 2 is plus or minus root of 1 plus cos theta by 2. Tan theta by 2 is, it can be said in two formats. It's the same concept. We have put it in different formats. Sin theta by 1 plus cos theta or 1 minus cos theta by sin theta. Many formats you can say. In other words, it can be even sin theta by 2 by cos theta by 2. If you take these two ratios, the first and second, it is sin theta by 2. So it can be said as sin theta by 1 plus cos theta or 1 minus cos theta by sin theta. Coming into the angles, friends, all these angles are measured and it has been systematically set. I have taken here only 0 to 90. The rest can be again further set on this. See, sin theta, for 0 degrees it is 0. Sin 30, half. Sin 45, 1 by root 2. Sin 60, root 3 by 2. And sin 90, it is 1. Since sin 0 is 0, please remember, sin 0 is 0. Sin 360 will be 0. Sin 360 will be 0. Sin 180 will be 0. Can you get this? 0, 0, well, back to 0. 0 in the start madadvi. We are going into just completely the second part format. 0, which was 0 degrees. 180 degrees it is 0. Coming back again is 0. Because everywhere sine is 0 actually with respect to all that. Whereas sine 90 is 1 and sine 270 will be minus 1. Why? In the third quadrant sine is negative. Okay. So 0, half, 1 by root 2, root 3 by 2, 1. Similarly, cos 0 is 1. Cos 30, root 3 by 2. See friends, this is the relationship that I... Sin 60, cos 30. Sin 30, cos 60. These things we must remember. That is exactly what we were talking about there. Sin of 90 minus theta, cos theta. Cos of 90 minus theta, sin theta. So sin of 90 minus 60 is cos 30. Correct? So that's what it is. Friends, this is very, very essential. Though it is very simple, many a times it gets stuck for us. So sin cos 30 is root 3 by 2. Cos 45, 1 by root 2. Cos 60, 1 by 2. And cos 90, it is 0. So if I go, since cos 0 is 1, cos 180 will be minus 1. Because when you are getting into the third quadrant, cos is negative over there. Cos 60 back again, cos 360, again it is 1. So 0, 180, 360. You need to move like that. Here cos 90 is 0. Definitely cos 270 is 0 in that. In fact, see, you are moving into the fourth quadrant from there. In fact, it is 0. So we don't speak much about it. Tan theta is 0. Tan 30, 1 by root 3. Tan 45, very easy and simple to remember. Tan 45 is 1. Tan 60, see the tan 30 and tan 60 relations only. Tan 60 root 3 and tan 90 is not defined, because what happens is sine by cos it becomes tan 90. If I take sin theta, sin 90 is 1, cos 90 is 0. 1 by 0 is infinity it becomes, so it is not defined. So friends, we need to be very careful in terms of tan when we are going about. There are many angles that can be set easily within 90 degrees. Above that, it leads to confusions. Similarly, tan 180 is going to be 0. So tan 270 cannot be defined. It's a undefined value. See, it's all the same concepts what we reciprocated. So cosec 0 is not defined. Can you tell me why? It is 1 by sine theta 1 by 0. Cosec 30 is 2 because sine 30 is half. All reciprocal values we are writing here after. Cosec 45 is root 2 because sine 45 is 1 by root 2. Cosec 60 is 2 by root 3 because sine 60 was root 3 by 2. So it's all, I can say, mirror images. The reciprocal values of it. 1 by you put it, you get its value. Sine 90 is 1. So definitely cosec 1 by 1 remains as 1. Now sec, same case of cos. Cos 0 was 0. So sec 0 is 1. Cos 30 is root 3 by 2, so sec 30 became 2 by root 3. Cos 45 was 1 by root 2, sec 45 is reverse of it. Denominator of denominator, so it's going to the numerator, so it is root 2. Sec 60 is 2 because cos 60 is 1 by 2. Whereas you see cos 90 was 1 by, it is 0, so sec 90 is 1 by 0, which becomes not defined. Infinite values, it cannot be defined. Cot theta, again same concept. See, cos 0 is 0. Sorry, tan 0 is 0. Cot is 1 by tan. 1 by 0 it is not defined. Now all tan is reciprocated here. Tan 30 is 1 by root 3. So cot 30 is root 3. Tan 45 was 1. So cot 45 is definitely 1. Tan 60 is root 3. Tan 60 is cot 60 is 1 by root 3. Whereas tan 90 was not defined. Cot 90, what happened? 0 by 1, it is 0. Did you get this, friends? Okay. So this, if we remember, majority of the problems can be solved. Now let me go into the problems. I want you to answer it. Those who have a clarity about this, please give me an answer. First question, which of the following is not an identity? You can see it over there. Sin square A plus cos square A equals 1. Sin A equals tan A into cos A. 1 plus cot square A is cosec square A. 1 minus sec square A is tan square A. Over to you for the options. So the right answer here is D. 1 minus sec square A equals tan square A is not an identity. Friends, I did not stress on the question. The reason is, I'm sure many of you must have gone with the which is an identity here. So there are so many, all A, B, C are identities only. But the one which is not an identity, because 1 plus sec square A is tan square A, it is not 1 minus sec square A. Am I right? Forgot, sir, already all confusions. See here, 1 plus tan square theta is sec square theta. So 1 minus, the question is there 1 minus tan square theta. Sorry, 1 minus sec square theta. 1 minus sec square theta, what it will be? Minus tan square theta. And they have set it as tan square theta. So it's not an identity. Is this clear, friends? Small confusions will lead to the problems. Second question, sin t, this is cos square t. I'm sorry, I was not able to write square here. It should have been sin t plus cos square t by sin t. Sin t plus cos square t by sin t. What is its value? So cos square t is here. Take the LCM. It will become sin square t plus cos square t by sin t. Numerator it is 1. 1 by sin t is cosec t. This is the answer B. Second question is B is the answer. Third question. Which of the following is not an identity? Which amongst these is not an identity? Is just see, and please understand the second option is sin square a is 1 minus cos square a, sin of minus t is minus sin t, secant of minus t is secant t. So all these three are identities, whereas this is not. See here, tan 2 theta is my 2 tan theta by 1 minus tan square theta, but rest all they have given this. Sin of minus theta is minus sin theta. One more was on secant, so that I have not written here. When you have it in cos, see it is similar to cos. Secant of minus theta and cos of minus theta one and the same. It will be positive value. Okay, and sin square a is 1 minus cos square a. So first one is not an identity. Friends, very simple questions. You get confused and you go with something else. You need to be very careful. Here, fourth is you need to be careful. Which of the following is an identity? Is an identity. First one, sin square u equals 1 plus cos square u. Cot u equals sin u into cos u. Sin square u equals 1 minus 1 by secant square u. Cos of minus u is minus cos u. So here you need to tell me which is an identity. First is wrong. Second, it is not correct. Third, sin square u is equal to 1 minus 1 by sec square u. 1 by sec square u is how much? Cos square u. So 1 minus cos square u is definitely sin square u. So third one is an identity. Hope you are getting this. Now fifth and sixth are connected to the graphs, friends. As I was talking to you about where all what is positive, what is negative, we can go with this and answer it. What is the period of the graph in the below? We have started with minus 3 pi by 4, went to pi by 2, again it has come to pi by 4, 5 pi by 4. So 5 pi by 4, pi by 4 and 3 pi by 4. So if you take this, what is it going to give us? Just have a look at it and tell the whole periodicity. In fact, if you rotate this half of the image back to this, what is that you are going to get? If you can see that, I think you are done with it. 5 pi by 4, pi by 4, 3 pi by 4. Anybody? Any guesses? Is there anyone who has got the answer as 2 pi? The answer to this question is 2 pi, because it's a one sinusoidal movement and the period of the graph between 5 pi by 4 and 3 pi by 4 is 2 pi radians. You can see that 1, 2, 3, 4, 1, 2, 3, 4. The distance is 1, 2, 3, 4, 1, 2, 3 and 4. The period movement of the graph is equal over there. 180 this way, the another way 180. It will be 360 degrees. One more question. quite often this kind of questions have come in the CET papers. Which of the function below correspond to the given graph? Which is answering this? Any guesses? That is why we have that name also for this kind of curves. This you see in the oscilloscopes. This you see in the ventilator graphs, ECG machines. All these places this graph is seen. That's why the name also is given like that. The answer is y is equal to minus sin x. It's a sinusoidal value. So y equals minus sin x is represented here. Okay. Oh, I'm sorry. The previous question, it is y equals minus sine 2 pi x. It is n number of values, 2 pi. Y is equal to minus sine 2 pi x. There are many 2 pi's connectivities. 1 function, 2, 3 like this. There are n numbers. So 2 pi x values it is. Y is equal to minus sine 2 pi x. Coming into this. If t lies between 0 and 2 pi such that sin t equals root 2 by 2 and cot t less than 0, then t is what? What is the value of t? Please go ahead. T lies between 0 and 2 pi and sin t is given as root 2 by 2. Root 2 by 2 is actually 1 by root 2. And cot t is less than 0. What can be t? Think over it. You will have 30 seconds to think, but think very validly. T has to exist between 0 and 2 pi, and sin t they have given for you to understand. It is, so sin t is 1 by root 2 means it is 45 degrees. Okay. So in terms of cot t, it is less than 0. So what is t? If you say pi by 4 as 45, you are wrong. Because t lies between 0 and 2 pi. And cot t is less than 0. The answer is 3 pi by 4. You need to be very careful, friends, while taking up this kind of questions. Next, if t lies between minus 2 pi and 0, t lies between minus 2 pi and 0, and sin t is minus half. Be careful, one minus exists here. It's not just plus. So if it would have plus, we could have written it as sin 30. It's not sin 30. Minus half is here. So sin is negative in 2 quadrants, that is third and fourth. So you need to be careful, and t lies between minus 2 pi and 0. Got it? What is the value of t in this? Anybody? Yeah, exactly. The right answer here is minus 5 pi by 6. Minus 5 pi by 6 is the value of t. Those who have got it, clap for yourself. Those who have never got, or those who are not able to get it, please work on it, because the indication here is sin t is minus half. It's not plus half. Be careful. Another interesting question. Cos x plus cos pi by pi minus x is equal to how much? Cos x plus cos pi minus x is how much? Cos of 180 minus theta, what did I say? When there is 180, cos remains as cos. But in the second quadrant, cos will be positive. It is minus cos x. Cos x minus cos x. The whole world knows that this value is found out by Indians. That is 0. Is that clear? Friends, by confusion, we get into so many things, we don't see 0 in this sum. And when you are moving in a rapid movement in your CET, JEE exams, you make a lot of mistakes with this kind of sums. It is a very simple sum, should never make it. And sometimes it comes to your mind, cos of minus theta is cos theta, so I'll take it as plus. Please don't do all such mistakes. It's very simple thing, 180 minus theta. 180 minus theta goes into the second quadrant, and in second quadrant cos is always negative. Next, which of the following is not same as tan t? So interesting, so thought-provoking. Which of the following is not the same as tan t? Not the same. It is not same. It is not the same, they are asking. Any guesses? Difficult to guess or easy? Exactly. The fourth one is the right option, tan of 90 plus theta. When you say tan of 90 plus theta, it becomes cot theta. Never it is again tan theta there. And please remember, tan of 90 plus theta is what? Cot theta. But in second quadrant, tan is negative. So it becomes minus tan theta. In rest all the cases, it is same. So minus of tan of minus t, minus into minus becomes plus tan t. Tan of 360 plus t, first quadrant, tan t. Tan of 180 plus t, third quadrant, tan t. All first A, B, C are tan t's, whereas in the third one, it is minus cot t. An interesting logical question. This is very oftenly asked. So I just took this for you. Anil looked up at the top of a lighthouse. We normally take this kind of questions under heights and distances. Very good. So Anil looked up at the top of a lighthouse from his boat and found an angle of elevation to be 30 degrees. After sailing in a straight line 50 meters towards the lighthouse, he found the angle of elevation to be 45 degrees. You need to find the height of the lighthouse. Here BC is the lighthouse and its height need to be calculated. Let's take it as h. He was first at 30 degrees. That was A point. He moved 50 meters. Then he came down to a point called D, from where the elevation was 45. Now the distance between D and B, which is not known, it is taken as x. Do we need that as the answer? No, we don't want that. Now please understand, in this triangle DBC, DBC, this is 45, this is 90. So this angle DCB is 45 degrees. So it is an isosceles triangle. If this is X, this will be X, friends. 50% of the answer we got it. Now how do we connect this? Can we take the full triangle? Tan 30 equals X by 50 plus X. Tan 30 equals X by 50 plus X. Tan 30 is how much? 1 by root 3, that is equal to X by 50 plus X. So X into root 3 minus 1 is equal to 50, or X is equal to 25 into root 3 plus 1. And the right answer is D. Very simple. At the same time, even one small mistake will make you to get into a lot of mistakes. In this question, it can also be taken as tan 45 is equal to opposite by adjacent. This opposite is h. If I say h by x is 45, which is 1. So h is equal to x. So these two become same. Either of the ways you can say. First I said saying it as an isosceles triangle. In the second case I proved it to you using tan theta. Both are one and the same. Any way you want you can take it, but make sure you reach the right answer. Friends, for your sake only, they have given 3 close answers. One is to 25 root 3 plus 1, 25 root 3 minus 1, 25 into root 3. Anywhere, see if you are stuck here, x into root 3 minus 1 is equal to 50 and x is equal to, so root 3 minus 1 has gone down. We may go with the answer, oh it will be 50 is there, it will become 25. We should not go with that kind of guesses. It is root 3 minus 1 in the denominator, you need to rationalize it. So when you do that, you get this 25 plus into root 3 plus 1 as the answer. Hope this concept is clear to you. I'll go with one more problem. Friends, an airplane is flying 3000 meters above the ground, passes vertically above another plane. Interesting one. There is one flight which is traveling at 3000 meters above from the ground, passes vertically above another plane at an instant when the angle of elevation of the two planes from the same point on the ground are 60 and 45 degrees. Interesting. Okay. The height of the lower plane from the ground. This is the point where one flight exists, the other flight is here P. This is ground R. Now the total height is 3000 meters for the first flight. We need to find the second flight, how far it is above the ground. We are not finding this height, we are finding this height from ground to top. This is the one confusion many of students get into it. Second flight's distance from the down part, from the base we are trying to calculate. Let the height of the plane which is flying, let's take it as at an angle called P, at a point called P with the angle of elevation 60 degrees. The full is 60. Friends, RQP is 60. Please be clear. Whereas RQ, this if I say M, RQM will be 45 degrees. And this is H. Now we need to take the relationship like this. Tan 60. Tan 60 is how much? Opposite by adjacent. Now friends, as I said in the previous concept, same thing. This is 45, this will be 45. So this is h, this is h. Both are same. This distance is also h. This distance is... Sir, this looks too big and this looks small. Don't go with that kind of logics. Actually, while drawing, you must have seen flights are seen above us, but it will be traveling at a greater height. So friends, this distance and this is actually same as per the logic. Don't go by the figure. Okay, so tan 60 is 3000 by h. If I get h, that's the answer what I need. So what is h equal to? 3000 by root 3. 3000 by root 3 is said as root 3, which becomes 3000 root 3 by 3. So 1000 root 3 is the answer. That is B. Friends, these questions what I have discussed with you are very, very important questions. See, I have started today's journey with the 6 trigonometric functions. After that, I took you into the area where a lot of formulas came into the practice. We discussed most of the trigonometric basic formulas that are required for the identity calculations. Then I took the journey into some of the very important calculations, finding the angles, collecting the properties, the graph concept. Graph is very, very essential, friends. You get a lot of questions from the graph many a times nowadays. It's one of the common thing that is happening. Followed by that, we did sums connected to the identification, like we identified the properties of identities and small confusions here and there. So you need to connect and get to know which is the right option in that. After that, I took you into the journey of 2 major concepts of heights and distances, which are very vital, and these 2 problems are very well discussed in the examination. Now there is one set of multiple angles that I am taking you. I will not discuss all these angles today. Just have a look at it and then tell me what may be the answers for the 3 questions that are there on your screen. This is for you to enjoy the trigonometric identities of my class. Trigonometric identity is one such concept which tells you a lot of information about its various applications. Yeah, please go ahead. Sin t is given as 0.6 and cot t is greater than 0. What is sin 2t here? Sin t is given as 0.6. Cot t is greater than 0. What is sin 2t? And you have a formula there, 2 sin theta cos theta. Is there a way we can find cos theta from this? If you apply your mind, you will get it. Yes? Cos theta is sine of 90 minus theta. Very nice. If this strikes to your mind, you are done with it. So the real answer here is 0.96. 2 sine x into cos x. Excellent. Second question. Cos t equals 0.8. What is cos 2t? They have given cos t here. You need to find cos 2t. Which formula you will take? Okay. You will take 2 cos square x minus 1. 2 into 0.8 whole square minus 1. 0.8 whole square you should do 0.16 into 2, 0.32 minus 1. Yes. Third question. Tan x is equal to 5. What is tan 2x? 2 tan x by 1 minus tan square x. If you do it, you will get it. 2 into 5 by 1 minus 5 whole square. The answer is minus 5 by 12. That's it for the day, friends. I wish you all the very best. I'll be coming with one more class with one more concept. This is Dr. C.K. Manjunath signing off from the Unacademy side, teaching you the concepts of trigonometric identities. For any doubts, for any clarifications, you can always come back to us. You can watch our channels for more clarity, for more doubts clearances. We have experts here who teach you varied concepts. Please take the advantage of this courses and make sure that you win through the situation. I'm sure we're all running through very difficult situation, but as I said in the beginning, this year batch students, 2020 batch students will be remembered forever because they are real Corona warriors. All the very best. Thank you one and all. I sign off here. Have a good evening.